Hi there, in this video I'm going to go through another example of how we solve hyperbolic equations. So in particular I'm going to go through another case number one example. Case number one, remember, if the coefficient of x and if the powers are all ones in your equation, only use the hyperbolic definitions. Okay, so here goes. So in part B we're going to be solving this equation here. 2 hyperbolic cos x plus hyperbolic sine x is equal to 2. Okay, so I hope you can see that. So once again, the powers are ones. The coefficient of x is also 1. That means that we need to use the hyperbolic definitions. Okay, so in step number 1, so as a side note, we're going to be using the definition of hyperbolic cos and hyperbolic sine. So hyperbolic cos has the definition e to the x plus e to the minus x over 2. And hyperbolic sine, that has the definition e to the x minus e to the minus x over 2. Okay. So if I replace the definitions here in the equation, we're going to have 2 hyperbolic cos, which is e to the x plus e to the minus x over 2, plus, so a plus, hyperbolic sine, definition being e to the x minus e to the minus x over 2, that's equal to 2 on the right. Okay, so I want to get rid of this 2 in the denominator, so let's multiply throughout by 2. By doing so, we're going to have 2 e to the x plus e to the minus x plus e to the x minus e to the minus x. That's equal to 2 times the 2 here, that is 4. Okay, and if I expand further, we'll have 2e to the x plus 2e to the minus x plus e to the x minus e to the minus x, that's equal to 4. Okay, now if I simplify this, so we can simplify this even more, 2e to the x plus e to the x is 3e to the x. Okay, 2e to the minus x minus e to the minus x is e to the minus x, that's equal to 4 on the right hand side. Okay, now just as in the previous example, okay, we don't like negative powers, so I don't like negative powers, so I'm going to get rid of this negative power by multiplying throughout by e to the plus x. Okay, so if I multiply throughout by e to the plus x, we're going to have 3e to the x times e to the x is 3e to the 2x plus e to the x times e to the minus x, that is 1. Okay, that is equal to 4 times e to the x, 4e to the x. Okay, which if we rearrange this equation, so if I bring all terms in this case to one side, we're going to have 3e to the 2x minus 4e to the x plus 1, that's equal to 0. Okay, so that's going to take us to the next step, step 2. Okay, so if we refer to the previous example, step 2, so we're up to here. Now, in the previous example, I made it resemble a quadratic by making e to the 2x e to the x squared. So this exactly the same step happens here. So in our example here, currently, let's make e to the 2x e to the x squared. So since e to the 2x is e to the x squared, we can make this equation 3e to the x squared minus 4e to the x plus 1 is equal to 0. Okay, hope you can see that. And just as before, if I let t equal e to the x, we're going to have the quadratic 3t squared minus 4t plus 1 is equal to 0 to solve. Okay, that is exactly what I did in that previous example in part A, okay, of example 1 over here. Okay, so now we need to solve this quadratic, so let's go back to this current example, and we can do so by factorisation. So if we factorise, we're going to have, okay, our two factors being 3t minus 1 and t minus 1. Okay, so that's going to give us two values of t, either 3t minus 1 is equal to 0, which means the first value is 1 over 3. Hope you can see that. So let me continue on the reverse side. So we have another value of t arising from this equation, t minus 1 equals 0. So, or t minus 1 is equal to 0, which means that t equals 1. So that's going to take us to step number 3. So these are the t values bearing in mind. Okay, we need to calculate the x values for this equation here. So let's go back to the substitution that we used, t equals e to the x. So it's step number 3. So since t equals e to the x, so that's exactly the same steps that I've used in example 1 part A. So if we go back to step number 3 in this example, I've done exactly the same thing, working out the x values as a result. So let's work out the x value when t equals 1 over 3. So that is the first value of t. So when I replace, e to the x is 1 over 3. If I take logs or natural logs on both sides, x is ln 1 over 3. So I'll leave it like that. We have another value of t, so when t equals 1, e to the x is 1. By taking natural logs on both sides or logs on both sides, x is ln 1 being 0. Okay? So those are the steps in order to solve hyperbolic equations of this type. So remember, if the coefficients of x are both 1 and if the powers are all 1, that means only use the hyperbolic definitions to solve the equation in question. Okay, and those are the steps. So I hope you found this video helpful. Do related practice questions, and I hope to see you in the next video. Thank you.